that's time, because remember, this is going to be a scalar, right? That's going to be a scalar times whatever the vector is going to be. Okay, and that's really the main one. We're going to use that one enough today that you will have no problem getting that down. So again, just to make, there's not going to be a lot of these, but there'll be 2 or 3 questions again on this, just to make sure that you've done them enough to make sure that it gets in your brain. The only way to memorize things from me is to practice, or to recite them out loud, because I don't want to like make a song about projections. I don't think. Okay. No, you don't.
Where's the guitar?
All right, here we go. Sample 3. Oh, sample 3 or 2? Or 1? Sample 2? Okay, so we're going to say find the projection I did all the hard work on this question. Instead of saying that V was equal to 12 north, 28 degrees west, and all that stuff, I'm just going to tell you just the basic information. We'll just sub it in here. Okay, it says find the projection of V onto U. Where did I stop at? I think Matt, I stopped. Did I pick on you, Matt, or
No, not yet.
Okay. You're going to get the easiest one of the day. So sorry, Brennan, the easiest one of the day is coming right now, so you got the second easiest one. Matt, can you recite from memory or from your paper, please, the equation for the projection of V onto U, please? Go ahead.
So it's V dot U over V dot U times 2.
Now remember, this whole thing is going to be a number, right? That's all going to be a scalar on the left-hand side. Magnitude of U squared. If you write that as magnitude of U squared, yeah. And that's what we're going to do here right now. Okay. So what's V dot? Can I get where? Actually, Nathan, I'm going to pick on you. What is V dot U equal to, please? Just in general, just in the general equation for it. He's freezing. That's okay. Somebody help him. When you have an angle, what's the definition for V dot U when there's an angle there? Chris, go ahead.
Would it be square root?
Nope.
Then it would just be 8 times 12.
Yeah, well, let's just hold on here. So I'm going to write this as magnitude. I'll write it just in general first.
Oh.
All right, just in the general for that. All right, and Derek already said this is just going to be the magnitude of U squared. Now, the reason it goes to that technically is equal to magnitude U cos of 0, but cos of 0 is just equal to 1. And that's just times by U.
So when you consider these, you can cancel them out?
Yeah, in this case you can definitely.
Okay.
You can cancel it. So if you want to call this, if you want to use algebra, just this is the one you need here, right? Magnitude V cos theta all over magnitude of U. That there?
Yeah, but could you do the new again?
Because it's magnitude, you can't really. I guess we could say, you couldn't say it's in the direction of U because that's all you'd be left with is the direction then. Okay. So let's plug this in here quickly. So it's going to be 12 cos 39 all over 8 in the direction of U. And I can't do that in my head. I hope Anna can do that in her head though. 9.32. And that's in the direction of U. Okay, so whatever you would do that. Okay. Let's do one with Cartesian. Sorry for those that can't see at the bottom. All right, example 3 says,
Oh, no, yeah.
so that's
It's 9.32 divided by 8.
oh, divided by 8, sorry.
And so the final answer would be 1.1.
Oh, sorry. Start with that.
Times, it's times the vector
Times 8, so.
times 8 directed.
Yeah, time.
Wait.
Yeah, I guess, yes, technically that would be, so it'd be magnitude
Oh. So
which
the
is 9.32.
Oh.
9.32 in the direction of here.
I thought you just happened to not change it all, so.
Yeah, we'll leave that, we'll leave that one for right now. I'll explain, let's go to this one, because this is the one that's more. This is the one that's sort of the crux of today's lesson, is this one right here, okay? Okay, this is the one that you will be tested on and all that sort of stuff. Okay, so the projection of A onto B. So the way you write that is the projection of A onto B. All right, Cecilia, would you be brave, please, and tell me what the equation for that's going to be in English? Go ahead. Yeah. Good. Is everyone okay with how that's written up? Because that's the thing that gets people confused. They get the A's and the B's mixed up and call that B onto A. That's the main thing. People get confused on that. All right, James. How are you? Good, I'm glad to hear that. Can you please, oh, sorry, Teresa, go ahead.
So like, just making sure, when you say, like, is like the something one named always gonna be the one that you like?
Yes,
Like the
yes, yes. Yeah, if I say with a projection of whatever onto whatever, like the second one is the one with all the variables in it, okay? James, can you please tell me what A dot B means for these Cartesian vectors? Go ahead. Close? Close. But we're going to use these for these ones, okay? So go ahead. For these ones, what are we doing? No, just keep careful. Sorry, I don't mean that. Remember, for these ones, it has to be this times this plus this times this, right? So that's why that's what's a little confusing with this for this unit, because like these are two different things. So it's going to be 3 of -1. Okay, so everyone clear on the first part there? So it's going to be AX, BX, plus AY, BY. All right. Alistair, can you be brave, please, and do B dot B? What's that going to be, please? Okay, so go ahead. Yeah, BX, BX, plus BY, BY. All right, now I'm not going to pick on M, although you can answer if you want to. Remember that B is just a vector here, okay, right? So that's not dotted anything, that's not anything. All we're going to do is we're just going to put here -1, comma 8. Okay, right? Because that's just what your vector is going to be. Are we feeling sort of okay about that?
It's just there.
It's just, they're just numbers. No, because that's just a vector, right? So the idea is, this is like the scalar which you're multiplying it by. So going back to my original picture, sorry for that. U is still U, right? That's your original vector. All that we're finding the projection is going to be what you're multiplying it by. So it's going to be like the fraction or whatever is going to happen there. Okay, so it's going to be in this direction, so that's the -1, comma 8. It's still, that's your original vector. It's still going to be pointing in the same direction, but it's going to be how far along. That's what this is telling you, is how far along that vector is going to go. sort of, once you do a few of these are really easy. I know it's tricky right now because it looks weird, okay, but this is just calculation, that's all it is. Yes, right.
So like if we went back to like yesterday's note, would, what we're solving for be for A value?
Yes,
Okay.
right on. That's exactly what it'd be, right?
Okay.
Yeah, exactly. Okay, so I'm gonna do this out here. This is gonna be negative 43, I think, over 65. Someone confirm that for me? So that's 43 65ths. Oh boy. 323.44. Is that right? Someone confirm that for me? Someone confirm that for me? 43 times 8?
Yep.
Isn't that amazing?
That second number.
Oh, 43 times 8.
That's correct.
Okay.
Right,
That's
just,
good.
okay. I don't mean to, I'm sorry, Bill, I don't mean to be in attack mode. It happens some days, so, okay. Yeah.
Why is that different than the first one?
Because these are Cartesian vectors, right? So these are gonna be, these, when the vectors are in this form, you have to do it this way, that's what we're saying. When these are in the north, south, east, west, it has to go the other way. Right, that's just the whole thing, and that's, I have to show you two
There's two
versions of every,
ways.
I have to show you two, depending on which way the vectors are set up then, okay? All right, last example, which is type 3. Oh my God, it's almost 9 o'clock. Come on, one go, come on, guys. Number 3 is work. Okay, from physics class, I don't, now I know last people were upset because they didn't take physics. Don't worry about it, this is not gonna get you down, this is a very small example, one example is all this is. There may be a question on their assignment, there may be a question on their test, that's all it's gonna be is one, it's not the entire unit. So here we go, work.
Message, please. Emily Graham, Michael Duggan to the main office. Emily Graham, Michael Duggan.
So then the fourth.
Okay, so work is going to be force times displacement. And that's something you learn in physics, okay? Basically what that's going to be is the amount of work that you do depends on how much something moves, okay? The force you apply on it times how far it moves. So if I am, pushing on Austin's desk and it's not moving, I'm not actually doing any work, okay? The idea is if I start to move and all of a sudden the work will happen. That's the main thing. So this works out quite nicely for us to go on to example 4. An object is dragged 5 meters up a ramp under a force of 30 newtons. Apply at an angle of 40 degrees to the ramp. Okay, this looks complicated. Okay, it looks tremendously complicated. But it's not, okay? All the work is going to be is magnitude of force, magnitude of distance, cos of theta, which conveniently would be force dot displacement, okay? My force here is going to be 30. My displacement is 5 cosine of 40 degrees, and that's all there is to work. Okay? Just another application, but that's all there is to this. And I got an answer of 114.9. Hopefully that matched yours. 114.9. And that's a Newton. Is that a Newton? That's not a Newton. I have Newtons. Is that right? That's not right. Joules? Works in joules, right? What's work in? Joules. And as you can see, this one's the easiest of the three examples today. I think it's fair to say, is this one here. That's physics is easier than calculus. All right, and that's all I got for today. I feel bad I'm ripping you guys off 20 minutes every day, but
This was like 3 lessons though.
well, the middle part was heavy. The middle part was definitely heavy to wrap your mind around the projection stuff. And that's the stuff that's sort of the fundamental part for today is the projection. But this example 4 should have been easy. Example 1 should have been easy. Here's your homework for today, please. Now, I want to be in a good mood tomorrow, okay? So do me a favor and get your homework done. I want this to be so when you get, because tomorrow we're starting on to 3D stuff, okay? So which means it's everything we've done with just made it a little bit more difficult. Okay? Here we go. Homework. Brad, did you find your textbook? It's on your bed. Okay. If, just like last night, if you get to the end questions and they're getting a little tricky for you, that's fine, but I don't just want you to say, Mr. Sadler, I got number 5 done, okay, because that will not be acceptable tonight, okay? So, get in the zone, please, okay? If you've fallen off the homework course, I don't know if that's a thing, we'll get back on the homework course, okay? Anyone need to borrow a book? No? Guess you need to borrow a book?
I can.
You told me to